So today we're going to start chapter 7, the Laplace transform. And before I give you the formal definition from 7.1, the idea behind Laplace transforms is to transform an initial value problem from a differential equation into something algebraic, then solve it, and then transform it back. And this was named after the French mathematician Pierre-Simon Marquis Laplace. I think I said that right. And before I give you the definition, I want to talk about a couple concepts that we learned about in calculus that we're going to need in order to solve these Laplace transforms. So the first one is from Calc 3. So we have the integral from 1 to 2, 2x y squared dx. So this tells me what I'm integrating with respect to. The y variable is treated like a constant. So when I integrate that, I just get x squared, x squared y squared, and then I have to integrate it from 1 to 2. So when I plug in 2 into that, I get 4y squared, and when I plug in 1, I get y squared. So I end up with 3y squared. So I started with something with 2 variables, and I end up with 1 variable. The other concept is the improper integrals. And we're going to look specifically at the case where we have our endpoint, one of our endpoints at infinity. So improper integrals is number 2. And if I look at the integral from 1 to infinity, 1 over x dx, we do a rewrite, take the limit as b goes to infinity, 1 to b, 1 over x dx. And then we can integrate that. So the integral of 1 over x is the natural log of x. So I have ln of x from 1 to b. So when you take that limit as b goes to infinity, we get ln of b minus ln of 1. Well, as b goes to infinity, the natural log of b goes to infinity. So this term's going to infinity, minus 0. So I get infinity, and this integral diverges. Another example, if I'm going from 0 to infinity, e to the negative x dx, when I take that limit as b goes to infinity, so when we integrate that, we get that negative 1 out front. So this just becomes negative e to the negative x from 0 to b. So when I evaluate that, I end up with 1 over e to the infinity, because that negative, we're just bringing it down the bottom, minus negative 1 over e to the 0. So this term is going to 0. And then I get minus a negative 1, which is just 1. So this one does converge, and it converges to 1. So we're going to be using this. So not all of them are going to converge. Some of them are just going to blow up. But with the improper integrals, it's either going to diverge, goes to infinity, or will converge to some real number, and we can actually solve it. So back to our definition. So for a function f of t, the Laplace transform of f of t, and t has to be greater than 0, and we use the script L for Laplace transforms. So the Laplace transform of f of t is the integral from 0 to infinity, e to the negative st f of t dt. And that is going to equal capital F of s.